All right, question 9. In the diagram of circle T, the chords segment AB and segment O and HI are drawn in such a way that segment AB is congruent to segment HI. If the measure of angle ATB is equal to 2 times the quantity of x plus 5, and the measure of angle HTI is equal to the quantity of 3x plus 3 degrees, what is the value of x? Enter your answer as a number like this. If you didn't remember this from the lesson, if you have two chords that are the same length and you have this central angle formed, which means it comes and hits the center of the circle, that central angle is going to be the same as the other angle that's formed because this side AB is the same length as HI. So these two angles are going to be the same. So then that means that we have angle ATB is equal to the measure of angle HTI. We do know that the angle of ATB is equal to 2x times the quantity of x plus 5, and then we have HTI is equal to 3x plus 3. So I'm just going to substitute that in, and now we have something we can work with. So I want to first gather all of our x values onto one side. Question 8, this was already done and accomplished in the setup, and this one has values of x on the left hand side and on the right hand side of the equal sign. So first I want to gather all of my x's, which are like terms. So this 2 is going to distribute, which means we're going to multiply it to both of those items inside the parentheses. So 2 times x is 2x, and 2 times positive 5 is a positive 10. So that is what it simplifies to, equals, and this 3x plus 3 does not, it technically has a 1 being multiplied to it out in front. 1 doesn't change the value of anything, so it's 3x plus 3. So again, we still have our x values on this side, left side, and the x values on the right hand side. So I'm going to pick a side to move from. Since this value is larger than this value too, I'm going to subtract the 2x from both sides, and I'm matching them up with their like terms. So then we have 2x minus 2x, which leaves 0x. 0x means no quantity. 0 times x is 0, so that's why it's not written. It's because it's 0x. And 10, positive 10 plus nothing is still a positive 10. Typically, it's just written, since it's positive, it's just written as 10. It's implied that it's positive. So 3x minus 2x leaves 1x. Positive 3 plus nothing still leaves a positive 3, so plus 3. So now we have the 1x, which is typically just written as x. On the right-hand side, there's no more x's on the left-hand side. So now I'm going to move my numbers onto the left-hand side. So all of the x's are on one side and all of the numbers are on the other. So we have plus 3, so I'm going to subtract 3 to both sides. So we have 10 minus 3, which is 7. And then we have that equal to x minus nothing is still 1x, or just written as x since the 1 is applied. 3 minus 3 is plus 0. Since 0 doesn't change the value of anything, it's typically left off. So now we have x equals 7. That was exactly what we wanted to figure out. So the value of x is 7.